So we're going to go back to more fundamental things. So I'm going to comment this thing out here. And there we go. So yeah, once again, one thing you really want to be able, when you deal with that kind of software, is to be able to look at the output of the program. Because, all right, very often with time and experience, you learn how to detect problems just by hearing them. And, but sometimes it doesn't really help, you know, and sometimes it's actually better to be able to plot the output of a Faust code, you know, and just to see what it's outputting, you know, and very often it's going to help you. So let's say that I'm going to create a sine wave, and I'm going to, I want to be able to plot this sine wave, okay. So for now, I'm going to give it a pretty low frequency so that I don't have to make a giant plot. Or, no, actually a pretty high frequency so that I don't have to make a giant plot, sorry. So I'm going to say 440 hertz, okay? And I'm going to save that. Okay, so I do have a sine wave. So unfortunately, we won't be able to do this in Faust Live. Because the problem is that you can't do that in Faust Live. So we're going to have to use the terminal to do that kind of things, because that's like more advanced features, basically. So, okay. So if I go in my terminal, I'm going to have to cd first. So go with my terminal in the directory, in the folder where this file is saved. Okay, so to do that, okay, I'm going to start right from the beginning. Oh, wait, okay, so when I open my terminal, if I say cd and then cd drive, so by default, my terminal opens in my home directory. Okay, and that's the same on the Mac. Then if I say cd drive, which is the location where my file is, so cd drive / Faust workshop. So just to prove you that I'm not lying, if I go in my home directory, I have a folder called drive, and this folder has a subfolder called Faust workshop. That's the folder that I have here. Okay. I opened it. This folder has a subfolder called D2. So I'm going to put D2 in here, and then I'm going to press the return key so that I go in this folder. Now if I do ls, there we go. I can see d2.cpp and d2.dsp, which are the two guys that I have here. d2.dsp is the file that I'm editing since this morning. Okay. And that's the file that I want to plot. There are several ways of doing that, but the most convenient one, I think, we're going to try, is to say Faust to plot. Okay, and then the name of the file. So Faust to plot.dsp. Then it's going to do something. There we go. It did something. Now if I look at my folder, I see that I have a little program that was created. A little executable program. Okay, so if I do ls, I can see the program. So now, if I run this program in the terminal, and to run the program in the terminal, I say ./d2. Okay. I think it's the same on the Mac, right? I know there is a, yeah, no, it should work on the Mac. Okay. Then if I press return, boom. This program outputs something. And this something is basically a MATLAB file. So if I run this program, and if I say, so let me clear that so it's very visible. So if I run the little program that I created, so ./d2, okay? And then if I use this sign here, and if I say d2.ls, .m, I'm actually asking my terminal to save what this program here returns into a file called d2.m. Okay? There we go. So now, if I go in my folder, I have a file called d2.m. See it? So if I open it in gedit, here is the file. And this file is a MATLAB file. Yeah. The values that I have here are the output of my Faust program. So if I plot that, it's going to be a sine wave. It's going to be a very short sine wave. It's only going to be the beginning of a sine. Yes?
Sorry, can you repeat again?
Yes, I will do it again. So once I am in the folder where my DSP code is, okay, I just say Faust to plot, and then d2.dsp, which is the name of the Faust file that I've been working with since this morning. Then I press return. Then a little program called d2, this guy here, is created. Now if I say ./d2, I do that to run this little program in the terminal. The thing is, if I just run this little program in the terminal as such, this little program is going to return that directly in the terminal. It's not very convenient. It's not very practical. Instead, I want to save what this little program returns into a file, into a text file. So to do that, I'm going to say ./d2, which is my program. And then I'm going to use this. How do you say that? How do you call that sign? It's like chevron?
Redirect.
Redirect?
What?
Yeah. But
What do you want to do, sorry?
no. How do you call that sign here?
Unix redirect in math.
No, but like in English, not in a
Bigger than.
redirect. Okay.
Angle bracket.
Angle bracket. Okay, redirect. So redirect and then d2.m. Okay, and then now if I open d2.m, I have this little MATLAB program. So far, so good? Okay.
How do you control the length of the...
Very good question. That's the next topic. So it's probably not going to be very helpful. So let me just try to run that quickly. It shouldn't work on your computer because unless you have Octave installed on your computer, but I think if I do Faust to Octave and d2.dsp, I haven't tried that. So it's going to be... Oh, it works. Works. Yeah, no, but they need to have Octave installed on their... Oh. So that's my sine wave. Okay, I'm gonna do a step-by-step thing so that you guys understand. Okay, very good. So I have my little program called D2. Okay. So if I run D2 in the terminal as such, I only get 10 different values. Okay. The thing is, those 10 different values, those values here are the samples of my sine wave. Okay. And I can totally see that it's going to be a sine wave, right? Because I see that I'm starting at a number near 0 and then 0.1, 0.2, 0.3. So I'm going up basically, right? But it's not enough to see the entire sine wave. So if I want to see the entire sine wave, I want to display more samples. To display more samples, my little program actually accepts options. Yes, and there is an option which is -n that is going to allow me to specify the number of samples that I want to have for the output. So if I say -n 100, boom, I got way more samples now. So now if I look at these numbers, I can totally see that it's a sine wave. So I'm starting at 0, then going up, going up, going up, going up, almost near 1. Okay, and then going down, going down, going down. Oh, and then it's negative. Okay, negative, 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 and then going up again. Okay, so I do have a sine wave, or I do have a series of numbers that represent a sine wave here. So those tools here are more, I'd say, more complex, more professional tools. So we're never going to use them in the frame of the workshop, but if you're really interested by that kind of stuff, you should definitely get used to that kind of thing. So the thing is, what we're generating here is a MATLAB file. So in order to be able to see what this is going to display, you need to have MATLAB installed on your computer or Octave. Octave is an open source version of MATLAB that you can download. It's free, and if you want to have fun tonight, you can download it. Don't do it now because Octave is gigantic. It's like 3 gigs. It's going to take forever to install on your computer, and it works on the Mac. And if you run this file in Octave, it will display the sine wave. And that's exactly what I was doing here, because I have Octave installed on this computer. So instead of doing Faust to plot, I can actually go directly. I can go directly to Octave without having to run the little program, and running the file that was created into Octave. I can just say Faust to Octave, okay, and then D2 what? What? Oh yeah, Faust. Thank you. Faust to Octave D2.dsp. And then if I run that, then my computer will automatically run this file in Octave. There we go. So that's a sine wave. It's very... So here too, I'm able to control the number of samples that I want to display. So annoying. Well, anyway, yeah, you guys won't be able to see more than that. But
does it just make an octave figure, or does it?
So what it does is that, yeah, because you were not there when I. No worries. So what it does is that it creates an array, which is like a MATLAB or an Octave array, fills it with samples. How many did I have? Shit. Okay, I'm gonna regenerate it because. So yeah, it creates. Yeah, that basically. So it's a MATLAB or an Octave array, and then it just says plot, and then puts a title to it, So well, the whole point here is that it's actually outputting the samples, and that you can use them in MATLAB or anything else if you want to plot them. So if you don't like Octave or MATLAB, you can use LibreOffice or Excel, and that should work too, I guess. Okay. So well, just while we're here, for people who use Linux, you. Well, you probably saw that there is Faust to LV2, Faust to LATSPA, but I'm sure you know about that. There is also Faust to DSSI, and so those work very well. And so Faust is a great match with Ardor because you can write something in Faust and then use it right away in Ardor, and it's very good, and that works great. So I really recommend you guys checking that out because it's very, very convenient. And Ardor works on the Mac. So that's fine. Okay, good. So now I'm going to switch to the Mac so that I can show you how to yes?
So is there, this you have a predefined input signal of an oscillator. Can you give it a signal?
Yes, you can. Yeah. You can even change the parameters. You can change the default parameters of your object if you want to. How do you do that, though? It is a good question. So I'm gonna try. I never do that. So I need to So if I go back to my Faust folder, and yeah, there I am. Oh no, I'm in D1, so yeah, I need to go in D2. So if I do D2.h, is it going to give me, yeah, wow, look at that. Yes. So actually, if you just give a file to the little program that you generated with a series of numbers and samples, basically one per line, it should just send it to the program. So you can do it. Any other questions? Okay, so what I'm going to do here is I'm going to try to make audio unit plugin for GarageBand. Okay, so in theory it should be very straightforward. So let me just do some quick cleaning in here. Very good. So maybe
we could increase the font size and maybe change the colors or something.
Oh yes, absolutely, yeah. So font size. There we go. Is it better? Nice. So here I've got the tremolo effect that we did yesterday. Okay. So we're going to use that as an example. Okay. So the thing is, very often audio effects are stereo, okay? And this tremolo here that we made yesterday is not stereo, it's mono. So if someone has an idea on how to turn this into a stereo effect, that very, very simply, you know, just in a normal way, how would I turn that into a stereo effect? No, not split. No, because then it's not going to be stereo. Then, because very often audio effects like audio plugins are going to take a stereo input. So you're going to have something on one channel, something on another channel. If you split, then you're going to mix things together, right? And you're going to turn your stereo signal into a mono signal. Yeah. No?
Tremolo, tremolo.
What?
Tremolo, tremolo.
Absolutely. So if I want to make it stereo effect, now it's stereo, right? Because now I have two tremolo in parallel. One is processing one side, one is processing the other side.
So it's not split?
Well, no, here it's not splitted. Here it is absolutely. So here I just got like two tremolo effects in parallel. Okay, and so one for one channel, one for another channel. Actually, I can probably look at the block diagram of this by going into the right folder. So where did I put that? I think it's in desktop, Faust works. And I'm going to do Faust to SVG, Tremolo. And then I'm going to do open Tremolo SVG process. Yeah, there we go. So we got two in parallel. Okay. So now it is stereo. So the way I'm going to turn that into a audio units plugin is simply, and so it might throw you a bunch of warnings. It's okay because the audio unit architecture is from last year, so some things have changed a little bit in the SDK, so it gives you warnings maybe if you try to compile. But if you say Faust to AU, and then the name of your DSP file. So you have to be careful because the name of the DSP file, so the name of your Faust file will become the name of your plugin. Okay, so Faust to AU tremolo.dsp. Then if I press return, then okay, it's doing what it has to do. It's complaining, but it's okay.
Can you make it bigger?
Yes, I will I don't know if I can make it bigger. Text. Change. There we go. Yeah? Better? Oh, that's a bit too big now. Okay. Here we go. Okay. So it worked. And the nice thing about it is that it actually, you know, I'm going to...
It just does it on the next new terminal. Or not.
Yes, as a default.
You have to set it as default, yeah.
Very fine.
So if the
Ah, okay. I see. So, default. Yeah, but now it's small. So, there we go. So now I have to go back to where I was. Okay. So just by running Faust to AU, in theory, should have installed your audio unit plugin. So you don't have to do anything. The place where it was installed is this place. So if you go in your home directory, in your home directory, there is a hidden directory. And this hidden directory is called library. So if I go in my file, in my Finder, and if I go in my home directory, I won't be able to see it. Okay? So if I want to see it, the only practical way to see it in the Finder, I guess, is to say just open library in your terminal from your home directory. Now, magically, it shows up in the Finder. Yeah? Do you get the trick, or? So what I did is that I just basically just open a new terminal window. And by opening a new terminal window, you're automatically in the home directory. Okay? And then you just say open, and then open library. Okay? And opening library will open the hidden folder in the Finder. Okay? Then in this, there are a bunch of stuff. But you see that there is actually an audio file. So I will go in the audio file. And in the audio file, there is a plugins file. And in the plugins file, there is components, DG design, and VST. And in components, tremolo.components. So there it is. Okay? So that's my audio unit plugin. And it was thrown in there.
Inside library slash what?
So it's library slash audio slash plugins slash components. And to make things a little bit more confusing, there is actually another library folder that is not in your home directory, and that is at the root of the hard drive. And that one has exactly the same structure than the one in your home directory, and except that that one you can only change things in it if you have root access. By default, we use that one because that one is more convenient for us, because you don't need root access to change things in it. Do you see the Tremolo.component in it, or? Yeah?
I get error message.
You get error message. But do you see Tremolo.component or? Yes?
Run Faust, the Faust 2 options on Windows.
So audio units don't work on Windows. The only, yeah, VST works though. So the best way to compile a VST on Windows is to use FastLive. And in FastLive, you go in the export option of FastLive. And in the export function of FastLive, you choose Windows and then VST. And that should do it. Okay, very good. So now if I open GarageBand, okay, if I open GarageBand,
And it should see these things in the
it should see them, yeah. So if I go in GarageBand, I'm just going to create a new project. Okay, and I'm going to create a new project with a piano. Okay, and I create it. We're just testing things out here. Like it's not going to be. Okay, so I got a piano. Does it make sound? No, the piano doesn't make sound. Okay, so let's say that I want to apply my tremolo to the piano. I'm going to go in Edit here. And in Edit, I can add effects. I'm going to click in here. And then I got a big list of effects. And in the audio unit effects, I have tremolo, which is the tremolo that I just created. So I'm going to click on it. There we go. Okay. So my tremolo effect is going to have a very ugly interface because that's what we did. So it's just a horizontal, well, two horizontal sliders and with frequency and depth, but I can try to see if it works. So now if I increase the depth, it works. So I got an audio unit plugin.